today's video will be on using set notation. So our learning goals for today, by the end of this lesson you'll be able to use set notation and the associated symbols and language to answer questions. Okay, so there's a lot of new words and symbols that we're going to learn today, so make sure you watch this video carefully, take notes, and if you need to you can rewatch it. So as we know, the sample space is a list of all the possible outcomes of an event or a trial. So we sometimes call it the universal set, and it's given a variety of symbols. So you can see all the different symbols it can be given, but we normally use this one here that kind of looks like a funny upside down U maybe, and it's called omega. So for instance, your sample space might be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if it was all the numbers from 1 to 10 inclusive. So A is a subset of the sample space if all the elements in A are contained in the sample space. So for instance, A could have the sample space 2, 3, 5, and 7, and you can see 2, 3, 5, and 7 all appear in our sample space. So A is a subset of our sample space. Now you can see we've got a bit of a funny symbol here that looks like a squished down C. That's the symbol we use for subset. So A dash is the complement of A. So as we know, that's all the complementary events of A, so everything but A. So for instance, the complement of A would be 1, 4, 6, 8, 9, and 10, because they are all the numbers that aren't contained within our sample space of A. A subset, sorry, of our sample space, which is A. So we've also got a new symbol here, which kind of looks like a curvy kind of E, and that's a symbol for elements. So 5EA, so if we've got that here, so you can see 5EA, that just means that 5 is an element of A. So if we look at our subset of A, you can see we've got 5 in there, which means it's an element of A. So 2 would also be an element of A, so would 3, and so would 7. So they're all found within A, so we say they're elements of A. So this kind of circle with a line through it here, this is what we call the null or the empty set, and it will contain no elements. So therefore, if you write to the sample space of the null set, you can see it's kind of empty, there's nothing in there. So for instance, it could be all the numbers less than 10 that are also greater than 100. So that doesn't exist, so it'll be an empty set. So it'll be a empty set or a null set, whatever you prefer to call it. So then NA, this kind of italics N, or you might see it written kind of like this, like a kind of curvy N. Either way, it'll be the same. It means the cardinal number A, and it's just saying how many elements are in A. So if we go back up to our sample space of A and we count how many elements are in it, we had 1, 2, 3, 4. So you can see there our cardinal number of A is 4 because there is 4 elements within A. Okay, so we're going to do a little bit of a practice one here. So a Venn diagram can be used to illustrate how different subsets in a sample space are grouped. So for instance, our omega, which is our entire sample space of the one we just did, is all the numbers from 1 to 10. We've also got two subsets, A and B, and we've got their sample spaces there. Okay, so we could draw that as a Venn diagram. So I'll draw our Venn diagram up. Obviously, in your case, you'd use a ruler to draw your box there. A circle for A, and our circle for B. Okay, so this A with a loop, like an upside down U, B, means A and B, which is the intersection of A and B, sorry, and includes all the elements that are in common with both sets. So if we look at our subset A and our subset B, and we look to see which elements they both have. So both have element 3, 5, and 7. Now, rather than populating our entire Venn diagram with all these numbers, it's easier and more productive really to just write the total number they have in common. So A and B both have an intersection of 3 numbers total, so I will just write 3 here, which means they both have 3 numbers in common. Okay, so this AUB, which means A or B, which means the union of A and B. So the union of A and B means all the elements which are either in A or B or both. So that's the total number that we found in this circle, in the intersection, or in B here. So you can see 1, 2, 3, 5, 7, and 9 are either in the subset A or the subset B. So that's a total of 1, 2, 3, 4, 5, 6 numbers that are found in both. So 6 numbers are found in A, B or the intersection of both, and that's 6 out of a total of 10 numbers, which means 4 will be found in neither. Now we still have to find the numbers that are only in A and only in B, and we can look at our subsets up there. So if we look at A, we can see that the only number that's found in A that isn't in B is 2. So there's one number that's only found in A. And then we'll look at B and see which numbers are found in B but not in A. So we've got 1 is found in B and not in A, and 9 is found in B and not in A. So it's a total of 2 numbers. So we'll write the 2 there. And then we can check that because we know we started with 10 numbers in our Amiga, so in our sample set. So we'll count up our total. So we had 3 that were found in both. So that was the numbers 3, 5, and 7. 1 number was only in A, which was 2. 2 numbers were only in B, which was our 1 and our 9, and there were 4 numbers which were found in neither. So if we add those together, 1 plus 3 is 4, plus 2 is 6, plus 4 is 10. So we have a total. So that does represent that data. So that's how we'll kind of turn it into a Venn diagram. Don't worry, I've got another worked example. We'll go through that as well. Okay, so sorry if I just jittered there. I live on a busy road and a huge truck came past which just ruined the audio. Anyway, so we've got another worked example here. So a number is chosen from the set of positive integers between 1 and 8 inclusive. So that means it's a positive number, it's a whole number, and it's all the numbers from 1 to 8 including 1 and 8. So if A is the set of odd numbers between 1 and 8 inclusive, and B is the set of prime numbers between 1 and 8 inclusive, we've got a number of questions there to answer. So for A, we're listing the sets. So this is all about our sample spaces. So for AI, it's the sample space. So that's our Amiga, so listing the total sample space, and it's all the positive numbers, including 1 and 8, up to 1 and 8, between 1 and 8, sorry. So 1, 2, 3, 4, 5, 6, 7, and 8. So that would be our total sample space. For our second one there, we have to list the sample space in A. So A is obviously the subset of our total sample space, so the numbers that are in A would include, A is the odd numbers between 1 and 8 inclusive. So that's 1, 3, 5, and 7. That would be our totals there. And for B, we're listing all the numbers within the subset, which is B, and that's the prime numbers between 1 and 8. So remember, 1 is not a prime number, so that will give us 2, 3, 5, and 7. Okay, so B, we have to draw a Venn diagram. So you'd get your ruler, obviously you're going to draw up your nice, neat Venn diagram. That's going to show mine up. Circle for A, and our circle for B. Okay, so start filling that in. So which numbers are found only in A? So if we look at our subset, which is A, and our subset, which is B, we'll find out that 1 is the only number that's only found in A, because A is made up of 1, 3, 5, and 7, and B is made up of 2, 3, 5, and 7. So 1 is the only unique number to A, and that's a total of 1 number, so we'll put a 1 here. Next is our intersection there, so which numbers are found in both A and B. So if we look at both of those, we've got 3, 5, and 7, 3, 5, and 7. So those 3 numbers are found in both, so we'll put a 3 here because there's 3 numbers. Our next one is B, which numbers are found only in B, and that's 2, which is just 1 number, so it's just 1 that's found only in B. And our last step is to look at which numbers are found in neither the subset A nor the subset B. So if we look up at our Amiga, our sample space there, we can see that 4, 6, and 8, so a total of 3 numbers, are found in neither A nor B. So if we add all those numbers on our Venn diagram together, we should get 8. So 1 plus 3 is 4, plus 1 is 5, plus 3 is 8. Yes, so we've obviously represented everything in our Venn diagram. Okay, so let's go to C. First question in C is, okay, so we've got our intersection of A and B. So which numbers are found in A and B, because it's asking us to list the set. So the set of numbers that are found in A and B are 3, 5, and 7. So those are the numbers that are in both of those sets. Okay, our next one is the union of A and B, so that means the numbers that are found in A or B or both. So that will be 1, 2, 3, 5, and 7, because 1 is found in A, 2 is found in B, and 3, 5, and 7 are found in both. Okay, our third one, oh, there's a typo there, I'll get rid of that, is A dash, so our complement of A. So what are the numbers that are the complement of A? So that means all the numbers not found in A. So that would be 2, 4, 6, and 8. So that would be our complement of A there. And our last one there is B only. So which numbers are found only in B? So if we look at our sample space for B, it's just 2. So 2 would be the only number found in B. Okay, so for D, I'm running out of space, so I'm going to go over here, but obviously you'd keep going down the page. It's asking us to find the number that are in A. So how many numbers total are in that subset A? So we've got 1, 2, 3, 4 numbers. So these 4 numbers are the ones that are found in A, so our answer there would be 4. Our next one is the probability that we draw a number that is in that subset A. So we know there's 4 of the numbers are found in A out of a total of 8 numbers. So it's 4 over 8, which is 1 over 2. So it's pretty much asking us what is the probability of drawing 1, 3, 5, or 7. So that's 4 numbers out of a total of 8 possible numbers. So it's 4 over 8. Our next one. Okay, so that's asking us the number that is found in the intersection of A and B. So we've got 3 numbers that are found in the intersection of A and B. And our last question is, what is the probability of drawing a number that's in the intersection of A and B? So obviously there's 3 numbers there, which was 3, 5, and 7, out of a total of 8 numbers. So that's 3 over 8. And we can't simplify that fraction any further, so we're just going to leave it like that. So that is an 8 there as well, not a 6. I think I just made that worse. So that is the end of today's video. If you have any questions, make sure you ask. I know it's a lot of new language and symbols, so have a go, practice it a bit. If you need to, watch the video again or whatever, please do so and come and ask any questions that you need to. But once you've practiced it a few times, it should become pretty familiar to you.